All right, what's up, everyone? Welcome to week 87 of building my own operating system. Today we're going to pick up where we left last time, which was with trying to parse the command line arguments passed from the bootloader, and doing so requires writing some multiboot code, like writing a multiboot parser, basically. So that is what I'm going to work on today. And we'll see how that goes. So the current state of the Git is, so we're working on some functions, or just literally one function from converting from physical address to a kernel virtual address. And then we were just testing this out a little bit. The reason we need this is because the OS receives a pointer to the multiboot header, but that pointer is a physical address, so we need to convert that to a virtual address. And so in the current design of the OS, it's simple because there's just the fixed mapping of all physical memory mapped into the top region of virtual memory. So it's just a simple addition of the kernel of the kern base, as it's called. It was called that in JOS. I could consider if there's a better name for that. I mean, maybe that's actually a good idea. Is kern base really, like, what is the kern base really? The kern base is the base address of the remapped physical memory. And so actually that name is a little bit weird. Maybe, I mean, yeah, we could probably imagine some better names for that. I think the fizz map is what people call this, or the linear mapping is what the Linux people call this. Security people call this the fizz map. And so K linear map, maybe. But I actually find the name fizz map more clear because of the word fizz in the name. So I'm gonna call that, I'll also go with that. So yeah, let's go with that. It's okay, fizz map. And so let's see, some things got updated. So I'll just amend this into here. But the thing is, entry.s, so mem layout is still used mostly just for kern base. And entry page dir also uses this. I think it's, it uses this for some of these other constants, like page table. Oh, that's MMU though, actually. So I think kern base is probably the only one. Yeah. And the only tricky thing is that, so then the layout is included from this assembly file. I remember this being a little bit awkward. So maybe I'll just make a constants file. But wait a sec, also, I wanted to make these things all C++, or I guess inline, even inline const expert auto, actually, now that I think about it. But entry.s probably cannot handle an inline const expert auto. It probably only handles defines. So that would mean there would be one .h file that has a constant, and then over here I include it and set it into the C++ variable or something like this. I am interested enough to try that. So constants .h. And so it's going to be define phys map base. And the pragma ones might also be problematic. But maybe I will F around and find out. So now over here, I'll include memory constants .h. I'll set this to this. And then now over in entry.s, I can include memory constants.h and I don't know, can I comment this out like so? Okay, so then, but actually this thing needs to be named kern. I wonder if this will even work. Did not seem to. So if I name this kern base, then I don't need it, then this code will be fine. And oh, this actually did get named. Okay, so let's just try that out. Okay, stack size. So there's more. Okay, let's just make a bootleg. Okay. So k-stack size is 8 page sizes, so now we're kind of getting into things here. So but here I don't need to be so precious with it, or 4096. And then k-stack size. Something like that. So now it has k-stack size. So it actually does build, which is pretty nice. And maybe it even runs. Yep, it ran. Okay. So now it's a good opportunity to boot stack size. Or maybe I'll just do this manually, I don't know. Boot stack size, and then over here, size, okay. And then fizz map base, something, I don't know, fizz map adder, fizz map base is maybe clear. Okay. Okay, look at that. So now we're using this, and then now I'll do fizzmap base. Maybe this is also called fizzmap base. Or maybe not. Okay, cool. So here we are add constants.h to declare fizz map base in one place. Right. The other place was here. So let's try the same trick. Constants.h. Is map base. Ooh, okay, so, ouch, okay. PTE is in mem layout. For some reason, PTET is declared in mem layout. Problematic, okay, but whatever. But I think we are building though, so cool. So this will go over here. And yeah, the more I think about it, I probably want to name this with base at the end to so what's the conflict? Should be pretty simple. Okay, base. Okay. Just double check this thing. So now this looks like this. It's a constant, and then in the next commit we make it use the macro. So that looks pretty good. Okay. So now that we got some of that a bit nicer, we can keep it moving and work on this multi-boot stuff. Okay. So, yeah, not totally sure, but multiboot2.hpp, maybe. And I don't really know, we're almost certainly going to need the multiboot2.h though for this. And probably, maybe we're going to have a class or something. And yeah, let's just take a brief review of this code over here, parse multiboot2 tags. So basically you just iterate through all the tags, and then you can just handle things. And so I'm sort of envisioning some code that maybe calls some callbacks for specific things. Like it's a function, maybe. You pass in the pointer to the blob or to the multiboot header, and then you pass in, maybe it's an object that has a bunch of methods, and those methods get called. Maybe they're even static methods. Those methods get called when particular things are encountered here. That's one design I can think of. So maybe I'll just make a new area for myself. 87. And this will be in so 28th. And then the caller can choose how to handle all the pieces of data. But yeah, I guess the idea is just to decouple the parsing code from the code that decides what to do with a piece of data that is parsed out. It could just also be a big monolithic object where you pass in the pointer, you call like .parse or something, and it internally has some fields, and then those get populated when you parse. It's just like, so what is the state of those fields before you call .parse? It's like this mutable object. Maybe that's not super nice, but maybe just to sketch it out. What would it look like to do this kind of weird idea of just to sketch it out. So we're going to boot to header, and then we'll call this multiboot2 callbacks. And let's see, like this, and then on bootloader name, for example. And then a bootloader name, but you get past something. You get past what is this thing? A char star or what? Probably just the char star. And then here you can decide what you want to do with that. And then maybe you put it in an object or something. I'm just gonna sketch this out. I'm just gonna, like, maybe this thing takes an object and then it's assigning data onto it. But really the question is, like, what's the, how do I want to use this data really? For the most part, it's literally just data I want to extract out of this blob and then be able to use in other places. Or the monolithic solution is this big object. It has like a parse method, slightly yucky. And then it's just going to have fields for the things that I care about. For example, it's going to have a field to store the bootloader name. And then but like what else? Does it store the command line arguments? Do we need to just keep that string around, or do we want to just pass that to some kind of command line argument parser or something like that? Or maybe we just don't need to keep it. Like, maybe we just don't need to store information. Like, maybe in this world with the on bootloader name handler, it's enough to just print it out and that's it. We don't need to store it somewhere. We can only store things if we really need to. So I don't know. I think I might just try this callbacks thing, because I can already kind of envision how it's going to go, something like this. Okay, weird. But, so whatever, I'm just going to do this. So, And then I'll just make the callbacks, construct it here. Right. Okay. And then the callbacks can decide what they want to do with that. But why? Still kind of curious what the compiler error is about. And there's no compiler error. Okay, so cool. And so this is not going to print anything because we haven't implemented this function yet. But maybe we can try to. So okay, so that's sort of where all this comes in. And I'll just, okay, I need to system clipboard. And I'll just get rid of some of this stuff for now. Interesting that the sorting, this comes later, maybe because of the 2. Okay, oh, interesting. So this actually can receive a multiboot header, a struct multiboot a multiboot info header. Is this a type? And why not? Oh. But is there a problem over here? I'm just gonna, okay. Okay, maybe that helps. Okay, so now in the main, we need to static cast. Not really sure about that one, but it's a maybe. Call that a maybe. Okay, good. So now, let's see, make lists. Okay, good. So now it's trying to compile all this code. And oh dang, okay. And we can think about how to improve this. Okay, so yeah, rounding. We don't have any rounding macros, so maybe that would be nice. Or rounding, I don't know, functions. So that sounds useful. But as a, I mean, I think it's actually still compiling because we do have them in types.h. Don't use roundup macro, use our own. Okay, so I'll just go ahead into all the C printfs, comment them out. And we could even do a log. Done parsing multiboot tags. And now, but then the cool thing here though is then now we do the callbacks dot on bootloader name p string dot string, right? And just out of curiosity, what kind of compiler wants in a main file? Okay, get rid of that. Type of. Okay. So this might be yeah, so this might be where we're using C++ and it's a C header, so we don't have type of or something, I guess. Just out of curiosity. This is kind of crazy. Can I decal type? I don't know. I mean, that's like kind of cursed, but that actually does work because we're in C++ now, so that actually did compile. So I'm just trying to get this to run in any way at all. And theoretically, this should get called and log this thing now. So let's try and check it out. That worked. Bootloader name, lemine 9.3.3. So I don't know, maybe there's better ways to do it, but I'm like somewhat happy with that. I just like that. So number one, there's no mutable object where you call .parse, and there's this intermediate state where you create the object, but all the fields are empty. I like that you don't need to store the data you don't care about storing. Like if we don't care about storing the bootloader name, we don't need to. We can just print it out and be done with it. So it's looking decent to me. I'm just curious. Let's check out this assertion. Let's just see a bit of an assertion in action. Assertion failed. Multiboot2.cpp24. Bam. We got some code. So pretty happy with that. Assertion sort of working there. So maybe it's just time for a quick commit. This is a whip. I'll just add this also. Whip multiboot parsing. All right, also probably a good time to clean up a lot of this. So we can convert these to log statements. Tag type. Size equals 8. Okay, maybe not. So how does this work? You get it's been a minute since I thought about this. You get the p tag, and it's this kind of somewhat generic. It's like the header, basically, if I recall correctly. I think data comes after it. So you take this pointer and you cast it to something else. All right, be right back. You take this pointer to the struct and you cast it to something different, like the string, and because they share the same layout for the type and the size, that works. So yeah, so this tag is a bit like this, the header, the first few members of a struct. Question, can I add a space here? No. Okay. Okay, we can C++ify a bit of this stuff. Could check that size equals 8. Okay, maybe I would need to break out my multiboot documentation. Maybe this thing could be broken out. All right, so maybe it's time to and so something like this. Tag. Oh, wait a sec. It is. So something. Handle tag, p tag, right. This thing is just a loop. It's just breaking. But we need to pass callbacks in order to have access to them. Cool. So then maybe this code goes away. This code gets kind of smaller. And then I don't know how happy I am with this whole loop, but that's what goes on here. We locate the location of the first tag by taking the multiboot2 header and then adding this, and then adding its size. Okay. And then from there we parse total size, boot info total size, and maybe this is print that out. The tag end thing is kind of interesting thing. I think this is mostly just a safety thing. In case for some reason something goes wrong with the iteration and doesn't stop, like in case there's no type 0 or something, we will at least stop when we hit the p tag end. Maybe there's a better name for that. Also, though, is this even... I'm a little bit surprised that this works out in terms of the pointer arithmetic. But maybe I am not remembering that correctly. Okay, so cool. So maybe I don't print the unknown tags. Got command line. All right, so we have all these new lines here. Got command line, hello world. But yeah, looks alright. I mean, to do, we could check that size equals 8. Maybe I just won't for now. I mean, I do actually, on second thought, feels like it would be good to check out the docs, at least slightly, to refresh on this. A fixed part and a series of tags, right? So the fixed part is this total size and then a reserved word. Total size of the boot info, including this field and terminating tag. Reserved is always set to 0'd and must be ignored by the OS image. Every tag begins with the following fields. Then you have these tags. So right, you need to get here, then you skip past it, and then you find a tag. I'm kind of wondering if I can make this a reference. But then there's these weird casts I need to do. Maybe that's all right. Then here I just need to, oops. No, I need to dereference it. Quick question, do I really need to do this conversion? What happens if I don't? Invalid operands to binary expression. Yep, cannot do that. No math on pointers. Alright, and then maybe I can just do like a first tag just to make this a little bit less let's make this for loop a little bit less unwieldy. Oops. Auto. Okay. Struct auto, what is that? Wait, what am I doing now? This is a pointer, yeah. Then yeah, I'm a little bit sketched out about doing this addition. I'm gonna ask real quick about that. It's safe to add boot info total size on line 45 like this. Aren't there pointer arithmetic problems? I feel like there would be, but it seems to be working in practice. Why is it working in practice? Okay, that's mysterious. Still is working. Cool. It's super odd. Boot info total size. Oh, because p tag end is never actually used. That's why. because it's a safeguard, and so in practice, it's never actually hitting this condition. I see. Auto. But do I really need to cast? I guess I do. And a static cast is not possible. And similar situation. And is this thing packed? No, but it's just 2 ints, so hopefully. So what? Okay. Tag and parsing multiboot2 tags. So we get the tag, cur tag. And the void, is that's really necessary, is that? No, okay. I mean, maybe we can even make this a, I don't know, using C++ iterators or something like that. Yeah, it's almost certainly possible to have a struct that's like the iterator, and then you do plus plus on it. Yeah, I don't have quite enough experience with that to say, like, how do you, like, the plus plus is only defined up to a certain point probably, so you need to know how far, you need to know whether it's valid to call plus plus. All right, whatever. And then on every one, we just assert the alignment and then handle the tag. And next, what does this do? So this is takes a tag which could maybe also probably be a reference. Does it have a problem? So then this thing becomes pointer, this thing becomes tag. And even, we don't need the struct because we're using C++, so it's just pretty sure that's right. Yep. Okay, and then over here, we dereference it. Nice. Okay, this is kind of coming into shape a little bit more. So right, so I'm printing out the bootloader name, unknown tags. Maybe, yeah, maybe that's not quite necessary. Yeah. It would be kind of neat to to test this somehow, like to have some kind of tests for this. That's an idea. So do a quick documentation. Oh, okay, time for a quick break. Be right back. Okay, so quick pros and cons of the different approaches. I mean, it sort of comes actually down to a couple of things. No mutable object with the .parse can control which data is stored and which is ephemeral, e.g. just printing out the serial, the bootloader name. Mutable object .parse has fields that store the data parsed out. And the description of this is just function that object with callbacks for various data types. Callbacks are simply called and client can choose what to do. And so I went with this one. Right, why was I doing this? All right, I totally forget what I was actually doing. But I wanted to document something. I mean, document this decision. All right, let's add another one. Let's on command line, and maybe we can. I mean, actually, so tags are terminated of a tag type 0 and size 8. So maybe let's just go back to the end and assert that tag dot size equals 8. Why not, since we have our new macro? So let's just so now we can get the command line, and it's called the boot command line. And it's also probably a string. So goodbye to this thing. I mean, these things could even be references, actually. And then something like this. Right? There's probably even a fancier way to compress this, where we store, I don't know, like a map or something, like look it up and then call some function to convert it to some type or whatever. So none of that really matters, so I'm not going to do it. Okay, so now we're officially in the line. Yeah, what's the name of this thing? Command line. And now, let's check that out. Seems to be working. So now here's the part where we would need to parse it or something. So let's. All right, but before we do that, let's just. So how's this commit looking now? CMake lists, add a bunch of code here, add this header, and add our first client. This is a bit of a mouthful. Fizz to vert, static cast it into this type. But what else can we do? Make a local variable, maybe. That's pretty much it. I mean, could it be a reference, though? That's always the question, isn't it? Okay, so let's say static cast it to, I mean, it's going to be a reinterpret cast here probably, but let's header. Expression must be. Okay. Whatever, I'm just gonna... Excuse me. And then all this changes, so now this is going to be like, I'm going to take a const reference. I'm going to call this header. Rather than now this just becomes header.total size. Address plus size of header, something like that. Thing turns into this. We're compiling and running, that's cool. Whoa, but I broke that boot info total size is totally wrong now. Too bad. I don't really think this would help, but I mean, just obviously the boot info size is totally wrong now. So something awful happened here. Okay, so let me, maybe I can just make it simpler. Okay, static cast, blah, 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 blah. Oh, wait, I need to dereference something somewhere, right? That's like, so I get a pointer and then that's the problem. That's the problem. Wait a sec, or is it? No. This pointer to an object gets reinterpret casted as a reference. So, okay, this is probably pretty simple, and I'm just not seeing it. So here's the old code. And that is working now, so get the void pointer, cast it to another type, dereference that, and that works. Get the void pointer, reinterpret cast it to a reference. It's something to do with the reinterpret cast to a reference. I sort of thought would be okay, but maybe not. So, what if this pointer is null though? Maybe we are guaranteed that it's not or something, but I'll just assert there anyway. So that's looking okay. Cool. So now that sort of brings us to the question of what do we do with the command line? And so here we want to, I don't know, use the frig thing, maybe. I don't think any of the other libraries I have offers command line parsing, so I don't really command line. So here's an example. So you make all right, let's try this. I guess my k-main would be the place for it. So check it out. We're gonna start using some frig stuff. And I'm just gonna do it like this, where oh, interesting. Okay. So the idea is to get the command line out of this thing and into somewhere else so it can be parsed. So I just really need to set a pointer somewhere. And I could even just const char command line or something. Right. What happened? Okay, yep. Messed that up. Something like that. So that's pretty easy. Okay, so then now I will have access to the command line. And let's say I wanted to, maybe let's start off with some easy bools. Bool. So I'm gonna have my, I don't know, let's just do a run through of some different types maybe. Does it really parse? You can tell it how to parse. That's interesting. My bool, my int, and even a string view. Interesting. My stir view. Right, and then so as number, my int, int, and then my stir, something like this. That's kind of neat. And then what do I do? Parse arguments. And you give it a string, in which case mine would be callbacks dot command line. And then what also the arguments. And then and then all your variables get filled in for you. So I'm just going to print out some of these things. Does this even work though? Can you print a data probably? So I'm just going to, so I haven't set any arguments yet. I'm just going to run this and see what happens. 0, 0, blank. Okay, so now it's time to pop over to the lemine.conf. And try setting something. So how does this work? Okay, we're gonna set foo baz yo quok. So okay, so it's kind of somewhat non-standard. My bool, my int equals 42, and my stir equals I am a stir, something like this. And let's see what happens. That did not work. So let's the command line is blank. Okay, so that's a problem. So what did I do wrong there? So, what? It's a null point. Sure. What? Did I do something idiotic? Like why? Hello. This smells like something kind of dumb. So, wait, what? I'm setting the command line, right? to this address. Okay, this is good. This has got to be something really stupid. Oh, it's because I forgot to pass by reference. That's why. At least I sort of thought that's what would be why. But also here. That'll do it. Okay, check that out. Wow. 142, I am a string. So that's kind of sick. We have some command line parsing. And what does as numbered do? So theoretically, I could use other types here, maybe. Like theoretically also, negative numbers work. Or not. But who needs negative numbers anyway? Or not. Value.to number. It returns an optional. Okay, yeah, it only handles positive numbers, which is probably fine. Cool. Okay, nice. Super happy with that. How does this work actually? Does it take a reference to, yeah, it takes references to various pieces of data. But wait a sec, toNumber is a template. So maybe there's different versions of it. No, a template is just used to store this thing. And then it just needs to be something that can be multiplied by 10, basically. Right, okay, nice. So check that out, that's kind of cool. Got some argument parsing going, and I am a string. Does this work? Not quite. Because the whole thing needs to be in a string. Something like that. But what? This was the original string I was passing in. Based on this test, it seems to so that's easy. There's no spaces. my string weirdly has a what? What about this? So wait, I can get rid of a few things. I can get rid of these two. Okay, that looks kind of buggy, maybe. But it would seem like this tests this case. Path 2. I'm not sure. I wonder if frig is slightly buggy here. Okay, I don't know. Not really important enough for me for the moment. Like, I believe I did this correctly. The boot command line prints out this, including the end quotes. And this my string seems to have a trailing quote, which makes me wonder if their tests are passing. But I do have a frig build, right? Couldn't I just try this? Or how do I print stuff out? It is suspicious. Why is the assert EQ colored differently? I think their tests are broken. And it's not testing something correctly. So, but how do I print something? Do I really need to include IO stream? Is that what we're doing? Oh, I just formatted the entire thing. Oops. Stupid. Good. And assert true, just to make the test fail. And I wonder, what happened? Oh, shit. Data. What? It's from my code just now. Is it from the formatting? Oh. Okay, might need to type this out again. Okay, let's try to. And it breaks compilation. Say without formatting. Damn, okay. All right, let's try this. Oh shit. Need to not hit save. Please. Oh, what? Oh shit. Fuck. Okay. Can I? What about this? Dang, keep doing that. Dang. There we go. There we go. Check it out. It's buggy. Oh. All right, do I file a? Yes, I do. All right. Shoes, new issue. I don't even really get that message that's being printed out. v3 dot data space no space. So this is the asked, and then weirdly, okay, it is getting way too much information here. All right, great. And then you can see this thing that I ran into just now. Okay, open source contribution done. Contribution in terms of a bug filed. Nice. So that's pretty solid work. Let me close this. Get back to my thing. So yeah, that's pretty cool. So now we have slightly, somewhat functional multi-boot parsing, and then command line parsing from that. And I don't really know, I don't actually have any command lines in mind right now, but maybe we can just add a test command line. Just as an example of how you might do this if you wanted to. And then, yeah, so I can imagine the command lines being passed to, I don't know, the actual kernel in some kind of way. Could imagine also some kind of like struct args. And then and then there's like this args test bool, but that doesn't compile. Oh wait, or does it? Wait, what? Oh, does compile, yep. Args, spec. Or just spec. Args spec. And then we could pass in the args to, for example, a kernel object. And it can do something with those. I don't really know. And that's our main. So I'm gonna actually go with this. Only thing though, for this we need to be careful. So I'm gonna do, I think I'll just only do, careful, Frig has a bug with, strings with spaces, inside. As of, I'll just copy some random commit. as of. Okay. And maybe, I don't know, there's potentially more information in here. And so I can imagine some kind of function that calls the parse multiboot and then does some post-processing on the data to get it to store it where it needs to go, and then just kind of returns this nice pack of data, which might be like a parsed args and maybe like an info struct or something like a system info struct or something like this for the data that we really want to store and keep around. Okay, so it's looking pretty good to me. So now I've done a lot of stuff all in this one commit, and maybe some stuff should be moved out. For example, technically the arg parsing stuff is kind of separate. There's actually even more. So this thing, the goal was to really just have some minimal code that does the multiboot stuff. And then we have this commit that tests out some of the parsing, add CLI parsing using frig. Check that out. All right. That was some pretty good progress. I'm pretty happy with how this went. We have a lot of basics covered now. We have logging, assertions, multiboot parsing, command line arguments, bootloader name or whatever, and we'll also be able to access the information about the amount of memory available on the machine, which is kind of important. So that will have to be for next time, though. I'm going to sign off, but thanks a lot for watching, and I'll catch you in the next one. Have a nice one.